Okay, so this is an explanation of the AutoCarve program. And essentially what the AutoCarve program does is it takes a binary file and it looks for signatures of known file types. And if it finds concatenated signatures, it goes ahead and splits them up and saves them out to separate files. So here we have usage, and it's a really easy usage. It's just AutoCarve and the in file. It will determine how to save them out. It just says carve 0 dot whatever, carve 1 dot extension, so forth. Okay, so we call this helper function load data file, and it just allocates and loads the binary into a buffer, and it handles all the error trapping and load file data, and will exit the program if there's some sort of an error that happens. So this is a pointer to the actual data that load file data returns, and we'll sort of talk about this. A lot of people are sort of fuzzy on pointers, so I might spend a bit of time. Index starts off at 0, so obviously we're starting at the very beginning of the file. File index is the length of the file, however many bytes it happens to have. So we're going to continue walking through this entire thing up until file length. So we have a helper function called getNextHeader. This tells it where to start. This will be populated with a type, and I have some defines that list the types. PNG type, GIF type, JPEG type, BMP type, text type, and I'm not handling zip type in this, so zip type actually isn't used. And what would be really nice is to actually add PDF type. So I'm hoping that some people for their assignment in week 9 will go ahead and add PDF type. So, but it'll return whatever define that is. And this is the start byte and what you have to add. The only thing about add is that the text type itself is kind of weird, because there's no, when it finds a block of text, there's no real header. It's just straight text. So there's a little finesse required there. There's the data buffer and the file length that gets passed to getNextHeader. That's just so we have the data buffer, so we know where to look, and file length, so we don't exceed the bounds of the array, because that would be the typical famous buffer out of range or out of range thing, which has been in the news so long. Okay, so current will return a null if it didn't find a next header. But if it doesn't return a null, that means we got it. And this just handles the extra for the text, and this just increments so it doesn't continue to find the same header. So here what we're doing is so we're just walking through the headers it finds, and essentially it just wants to know where the next header is, so that it's able to know how large this chunk is. Okay, we have to back up one, because we found a header, and we just want to make sure we don't miss it again when we come back. Here we save the file, call a helper function to save the file, and if next does equal null, we just want to set index to the file length so we can bail out of the while loop. Otherwise, we want to set index here in answer to this. If current equals null here, once again we're going to set index to file length so we bail out of the while loop. Okay, so let's take a look at this will be real quick. This is a bunch of support functions, the extensions I'm supporting. Here again, we probably should have, because I'm hoping someone will go ahead and get file length, load file data. This is one I discussed earlier, and it does all the error trapping. Save file data, that also does the error trapping. And finally, getNext is sort of where the it's actually where the intelligence is. So notice I've got the header data. One interesting thing about the JPEG is the header actually doesn't start at the very beginning of the chunk. It actually starts at offset 4 or fourth byte in. Okay, this is a helper function that just determines if something is text, and this is the getNext header. We're just checking for the PNG header. And by the way, in Linux I had to write my own _str and ICMP. Checking for the GIF header. If we find this, we set the type and we return where the header is. Set to GIF, return the header. So this is JPEG. This is kind of interesting. Notice that we have 4. In JPEG, there are 4 bytes actually before the JFIF. So we set to this. We tell it. We sort of adjust the start and we return the header. And this is actually the hard. Oh, BMP is not hard at all, actually. I find BMP. Now, the thing is, BM is actually probably a fairly common thing. So what I do is I point to the header, the image header data, and I just check for some sort of rational or sane values. Obviously, I'm not going to have one 10,000 with a width of 10,000, height of 10,000, and bit planes of 10. But those are, you know, anything less than that is going to be at least somewhere within the ballpark. Okay, set the type, return the header pointer. Now what I do, if I haven't found a header, what I'm going to do is I'm going to see how many characters of just straight text I have in a row. So this counts how many characters of straight text you have in a row. And if it found enough, and I arbitrarily set 100, this may be adjusted with testing. Set the type. I set what I'm going to add to it. Adjust the start and return the pointer. Otherwise, if I haven't found any of these, I'll return null. I'm hoping that someone in the class can add PDF and zip. So anyway, that's the rundown of this program. Hopefully you'll find it useful, and hopefully you'll find, you know, that I showed you how I did this program. Hopefully you'll find that useful for the whole idea of data hiding and data carving and anti-forensics tools. Okay, so let's go ahead and run this program. And just to let you know, Visual Studio lets you have command line parameters sort of built in, so you can test it within the IDE and not have to go to a command prompt. So I've got that C work test.png. So if I go ahead and run it, let's go ahead and start without debugging. And the command prompt will come up. And notice it saved carve0.png, carve1.gif, carve2.txt. And hopefully it'll do a really good job of finding whatever you happen to have concatenated. Right now it only handles those as 5 types, but hopefully I would say zip and PDF and maybe others. Anything that has a really strong header can be carved.